Hi, and welcome to this talk on MLOps in practice using Azure DevOps. My name is Erik, and I work as a senior data scientist at PensionDenmark. We're a pretty young department. We've been working for 2 years, and we're a team of 4 data scientists working on ML solutions. I was one of the first 2 hires in our ML team, and when we started out, we had a pretty good idea about how to build our DevOps setup. It seemed to us that there's just much more of an established idea about DevOps best practices. You want to version your code, and Git is the way to do it. You need to keep track of dependencies in production, and containerizing your solutions and deploying them as Docker containers is what pretty much everyone does. And for when it comes to DevOps deployment and building, there are just various CD, CI solutions, in our case Azure, that provide you with straightforward ways of building and deploying your microservices. But when it comes to MLOps, it seems, at least to me, that there's much less of an established best practice, probably because MLOps is such a new discipline. So when it came to our MLOps setup, we had to kind of figure out a best practice in our case, for our use case. Now, the way we did this was that we kind of took a step back and looked at our DevOps setup, because we came from DevOps, and what were we actually trying to solve with DevOps, and what did we need in order to have an MLOps system built on top of our DevOps setup. So DevOps, in essence, solves a software engineering problem. Specifically, it solves the problem of how to keep track of and deploy code and its dependencies. Now, when you're doing machine learning on top of software engineering, you simply have more moving parts. Now you need a way to keep track of not just your code and dependencies, but also data, accuracy metrics, hyperparameters, ML models, as well as deploying all of these ML models. So it just becomes more complex. You have more parts to keep track of. Now, if we try to sketch out the MLOps process, it looks a little bit like this. So what you have is that you have your data or your parameters, your code or your dependencies. And if any of these change, you would probably like to build a new model. So you have to train a new model when say, a new code base is published. And this new model has some new accuracy metrics, and you need to version them and store them somewhere where you can access them and look at them. And if these metrics are satisfactory, well, then you want to deploy your machine learning model. And when you've deployed your machine learning model, you now need to monitor it to make sure that it's actually working and not providing users with errors. So in essence, that is kind of the challenge that we were at least trying to solve with MLOps. And now, so this is how we did it. So our solution was kind of a pick and choose approach, where we built an MLOps system on top of our Azure DevOps setup. So rather than just adopting some complete MLOps solution, not even the one that Azure provides completely, because we didn't really like it. Sorry, Microsoft. So we took pretty much just our DevOps system and we enhanced it in certain ways. Now, the upside of that is that, of course, now we have more control. We didn't have to adopt a specific way of writing code and productionizing things that we didn't really care for. And we have good reason to be control freaks, because we work in finance and it's a highly regulated industry. And so we need a lot of control about our models and where they're stored and where data is stored and so on. But of course, there are other upsides. You don't have to wait for all kinds of new features. You can just add them yourself. But on the downside, it's more work, of course, and maybe that's why it's still a work in progress. But I think the core functionality is working in our setup, and that's that's what I want to show you in this talk. So, to start off with, the founding principle in our MLOps solution is to just separate everything that has to do with code from everything that has to do with ML models. So what this means in practice is that our code and dependencies that get bundled into Docker images that are saved to Azure Container Registry, which is just a Docker container registry that's hosted in Azure. But models, parameters, and metrics, those all get bundled into pickle files because we're using Python. And then that's saved in Azure ML Workshop. So we're using a little bit of Azure ML solutions. And so why separate code and models? The short answer is because the two are not identical, so mixing them up just makes it harder to keep track of things. So say that you're doing a weekly retraining, for example. It doesn't seem right to produce an entirely new Docker image every week just because the model has been retrained. The code base is still the same, so why do you need an entirely new Docker image? Now, if you separate the two, on the other hand, the same code base, so the same Docker image, can be used to train multiple models every Sunday, for instance. And Docker images now only need to be built when code changes, and models only need to be trained when there's new code or new data. Straightforward. And if something goes wrong when you've separated the two, you can always revert back to an old code base, so you can always revert back to an old Docker container, and now you can retrain a new model and use that new model with an old code base. So that when you separate the two things, it just becomes much easier to keep track of your code and your models. Now, we still need to link our code with our models, but since these models were, or we need to do this because these models were built from a specific code base. So new models might not work with an old code base and so on. And the way we do this is by tagging. So each Docker container has a build number, and each model has a model version, but it also has a Docker build number tag, which is the build number of the Docker container the model was trained inside. And this will all make much more sense when I show you how we train our models. But just know, we have a link, we have a tag that links the models with the Docker container. So the ML part with the code base. So the way we train models is that we use a pipeline in Azure to deploy a specific Docker container onto our dedicated train server. Now, for weekly retrainings, this could just be the Docker container that is currently running in production, because that's the model that you want to retrain. And then that could be triggered every Sunday. Anyways, our Docker containers are set up to run a Python script on launch that launches a Flask API, which then serves this ML model to the outside world. But when we deploy these containers on our train server, what we just need to do now is just to override the default CMD of the Docker container to run a train script instead. And inside that train script, data scientists have then specified how to train the model and score the model. And when that run is done, well, then the model and the score gets uploaded to Azure ML Workshop alongside this tag of what Docker container provided this model. So that's how we train models. When we deploy models, it's kind of similar. So as talked about, we simply just deploy a Docker container onto the server in the test or dev test or production environment. And when we deploy the Docker container, we provide it with an environment variable that the Docker container exposes to the Python script running inside of it on startup. And this environment variable contains the model version that this specific Docker container needs to run. And so this model version is just then used to request Azure ML Workshop for a specific model, and the model is then downloaded from Azure ML Workshop and then served as a Flask API on the Docker container. So in this way, we have a way to deploy specific versions of Docker containers and then tell these Docker containers what version of the model do you need to run. Do you need to run the newest one that was just trained, or do we actually need to deploy a previous version, and so on? So we just get this decoupling, which is very nice, between ML models and code, also in deployment. So I want to show you this in our DevOps system. So unfortunately, there probably won't be any spectacular live demo failures because I pre-recorded everything. But yeah, I'll just shift over to my screen, and I'll show you how this all works inside of DevOps.
And what you're seeing here is two pipelines. So there's a PD model Docker pipeline and a PD model train pipeline. And PD model is a dummy model that I've created, which is simply a model which uses the empty cars dataset to predict miles per gallon for various car makes. The PD model Docker pipeline is the one that produces a Docker image, so that's the code and the dependencies. And the PD model train pipeline is the pipeline that produces a new version of the model trained on the dataset. Now, if I were to run this PD model Docker pipeline, what would happen would be that I would produce a new Docker image, which gets uploaded to our Azure Docker container registry. This is the container registry, and as you can see, there are two versions of the code, so there are two Docker images, and they have been tagged with the model build pipeline tag, model build pipeline number, and this is actually just a date for when this pipeline was run, and then an increment. Now, if I were to run this train pipeline instead, well, I would then initiate this train process that I was talking about. So I could click it, and then I could run the pipeline and then specify in this variable section which Docker image to use to produce a new model. And when this training run is done, I would then upload a new model to our Azure ML Workshop. And what you're seeing here is all the versions that exist for this PD model in our Azure ML Workshop, and you can see the date when they were created. And if I click on this model, you can then see the properties that the model has. So there's a Docker build number, so you can see that this model was produced with this specific Docker container, which is the one ending with 25, which is this container right here. That's the one that produced the model. I could also show you that there's an artifact, which is this pickle file that I was talking about before. So this is the file that actually gets downloaded when you deploy this specific model. Now this pipeline is actually a weekly retraining pipeline. So this runs every Sunday. And the way this works is that you need to score the model that has been trained. And what happens is actually that we have this experiment, it's called an experiment in Azure, which is the weekly retraining of the model. Now, this is a pretty boring experiment because the empty cars dataset never gets updated, so the accuracy metrics actually never change. But if you can imagine if you had a dataset that gets updated every day or every week or what have you, you would get a different accuracy metric. So this here is the R-squared accuracy metrics for this specific model, and you can see that they're just stable. And you can customize all this to show different graphs and so on. But each run is then, of course, linked to a specific version of the model. So this is the version 16 of the model. So this is the newest one. And I can actually click on this specific run. And what you can see here is that we uploaded a bunch of different metrics with this run. So we uploaded how many rows of data was the model trained on, and we hashed the training data so we know if the training data has changed, and the R-squared value, of course. And you can add all kinds of metrics here to add more values that you want to log with this scoring run of your model. And you can also click on the model itself, and that would just bring you back to the view that I showed you before. There are all kinds of things you could do here to add more stuff to your model, which I think this works really well. Now, talking about releasing. So this is a release pipeline in Azure. And now that we've separated our code from our model, one nice thing that we can do now is that in this release pipeline, you can see we release to all kinds of different environments. And in this artifact section, you have the option to release a Docker image and an ML model. And now you can choose which Docker image you want to release. So, and you can also choose which version of the ML model you want to release. So say that you had some kind of mistake, some kind of error happens with the new model, and it's made this all the way to production. And what you can actually just do is just to say, okay, well, the code is working, but there's some kind of weird quirk with this new model that I trained. So let me just release the old model, the old version of the model instead. And if I click create, well, then I create a release of the model with this older version. All right, let's go back to the slideshow.
All right, back to the slideshow. I also promised to talk about testing and monitoring. So concerning unit testing, we don't do anything out of the ordinary. We just run PyTest during our Docker builds like everyone else, or at least like everyone else is supposed to. Although we do have some scanning that we perform with SonarQube, which looks for bugs, security vulnerabilities, and so on all our builds. But one thing we do, which we're really happy about, is that we perform API tests during our Docker deployment phase. So, for instance, when we deploy a Docker container, we query the REST API's test endpoint, and the test endpoint then executes a bunch of smoke tests. For example, a test of whether the model can actually make a prediction. So that would require access to SQL servers and so on. And those tests make sure that the model is actually running in each environment when we deploy. When it comes to monitoring, we use a service by Azure, which deploys on our Docker server and then scrapes all of the Docker logs for all the different Docker containers. In our case, those logs show the G-Unicorn logs. And those G-Unicorn logs, we scrape for errors, response time, as well as just simple usage statistics. And we've created a dashboard where all that information can be viewed. As well as we also create a bunch of applications which send out email alerts if a service starts to give errors on HTTP request. Although creating this nice and tidy dashboard is still a work in progress, but yeah, we're working on it. But as you can see on the bottom of the screen is a dump of a G-Unicorn log, and you can see that you get really nice information about usage and errors and response time at the end, which is something that we actually added by customizing the G-Unicorn logs. All right, that was it. That's our MLOps system at PensionDenmark. I hope that I provided you with some inspiration to maybe get you going with setting up your own MLOps system or improving your system and so on. So yeah, thank you for listening, and I'm looking forward to answering your questions.